So hello and welcome to today's Tech Talk on how to ship better plans, decision parameter testing and tuning in practice. My name is Haley. I'm part of the Next Move, now part of FICO team, and I'm joined today by Tiff Patella, who's on the platform and product side of the house for Decision Ops. So Tiff, thank you for joining us today.
Hey everyone, great to be here.
Excellent. Well, Tiff and I have a full half-hour plan for everybody here, and it's going to begin with a very brief orientation just to get everybody situated to today's topic on parameter testing. We're going to take a look at what is it and why bother doing it. And then we're going to spend the bulk of our time going through a tuning and testing demo that's going to begin with our problem statement. Tiff will walk us through a scenario test and then some ensemble runs in the end. We are going to close with some discussion and Q&A. So if you have any questions or comments, feel free to drop those into the chat off to the side. Just be mindful of that host and panelist versus everyone toggle to make sure your message goes to the right audience. You're also welcome to use the Q&A feature at the bottom of your screen, and we'll be monitoring that throughout. So with that, I'm going to get us set up with some quick context and then we'll dive into the demo. So we are all gathered here today because of the reality that most decision problems have more than one reasonable configuration. So put another way, effectively, your strategies only work until they don't. So you may have a routing problem where you have route clustering set up, and in some cases it's working just fine, and in others you might see that unassigned stops is crosses a threshold that's unacceptable. So there's a lot of use cases out there where you might see this. And Tiff, if you wanted to speak to something that you've seen in the field, I'd be curious what pops to mind for you.
Yeah, definitely. Actually, the example I'm going to walk through today for shift scheduling is another really common case where you're balancing costs and worker happiness. So we'll go into those details shortly.
Excellent. So the problem with this reality is that evaluating all these reasonable configurations efficiently is actually really challenging. So often you're having to either retune these trade-offs by hand or using a spreadsheet, and this really just doesn't scale. So the solution that we're going to look at today is how to use ensemble runs in Nextmove that allows you to systematically run multiple configurations and then auto-select the best one. So before we dive into seeing this, I want to make sure that we're all clear on two terms in that line, one being ensemble runs and the other one being Nextmove. And I'm going to start with the last one first. So Nextmove is a decision ops platform that kind of sits at the heart of your decision stack. It's one home, kind of one pane of glass for all of your decision applications. So you might have a decision application for pricing that maybe it's a prototype, proof of concept. You might have a routing app that's running in production. So regardless of technology, regardless of model maturity, all of these decision applications have a home in Nextmove. And Nextmove is really connected into all of these other decision stack pieces. So you might have a commercial or open source solver or modeling framework, various databases or Git infrastructure that you're hooking into, pipelines, visualization tools, web applications, or BI tools. So Nextmove is really designed to connect with all of these different pieces. So as you see here that there are these apps that sit within Nextmove. So we call them decision apps. If we were to zoom in on one of these, you can see that you're taking your decision code that's either local or Git managed and connecting it to Nextmove. And then you get this application that effectively contains all of the run history associated with that application. It's a complete history into who ran what and when with what input and output. You get a complete model and configuration registry that makes rolling out or rolling back or reusing models across different environments pretty seamless. And then you have a complete experimentation suite that allows you to be able to run anything from scenario tests to online shadow tests or switchback tests, and then be able to manage the input sets that go along with that. And then as you can see on the far side of the screen, there's a couple of different ways that you can interact with decision apps on Nextmove. So that might be via REST API, the CLI, SDK, MCP server, or Web UI. And we're going to spend some time largely in the Web UI today, but Tiff will give us a little preview of the MCP server as well. So now that we know what Nextmove is, what are ensembles in Nextmove? So an ensemble definition is something that lives within a Nextmove application, which you just saw, and it bundles together a set of run groups that you are interested in trying and the rules that decide which result wins. And then this definition is then applied to an application run. And you're going to see all this with Tiff here in just a moment, but the gist is you have an input that's a single request that feeds run groups. Then the outcome is ranked in priority order by the rules, and then a winner is selected. So let's see this in action. So we're going to walk through an example that is set within the world of our hypothetical demo company that we call the FarmShare company. So if you put your imagination hats on, both Tiff and I are employees at the FarmShare company. I am a planner and Tiff is the modeler. We are a consumer delivery service for farm-based goods, and we manage multiple decision applications inside of NextMove. That includes a scheduling application, inventory, pricing, and routing. So all these different applications in one central place. So recently, I've been receiving some feedback that workers are seeing uneven shift distribution. So some of them are getting, 5, 6, 7 shifts. Others are getting none. This is a problem because I care about making sure that we minimize worker churn. That cost of losing somebody and having to rehire is something that we are careful about from a business perspective. So I'm coming to TIFF today because I want to know what can we do about these unbalanced shift assignments, and then how can we be more resilient going forward. So with that, I'm going to hand it over to Tiff to walk us through how we do that.
Awesome. Thanks, Haley. Let me grab our screen share and I'm going to take us into NextMove console. So this is where all of our optimization applications for the FarmShare company live. And as Haley mentioned, there are multiple entry points to everything on NextMove. This is just one of them. It's the console UI. It's great for demos, but you can also access programmatically or through the MCP server and more. So let's take a look at the shift scheduling app. That's where we're experiencing some issues with our workers. We want to see what's going on. So every app in NextMove has the same look and feel. You have access to your run history. You can manage model versions and instances, set up experiments, and more. And I'll get into some of these features in more detail as we go. So our shift scheduling app is a Pyomo Highs MILP. It takes in workers and shifts and their availability constraints, and it assigns those workers to shifts with the objective of minimizing overall cost of the schedule and making sure that all shifts get covered. So that is our setup. You can see I pushed the latest executable. You have a view of recent runs that were made, tests that are set up, and things like that. So it's a nice kind of overview of what's going on. So let's dive into our run history. Haley mentioned that they were seeing some schedules that were live in production that are maybe not as balanced as we would like to keep our workers happy. So let's just look at the recent run and see what's going on. So here, and this is the same view for every run, we have a set of metrics. These are custom KPIs that were decided to be important by the business that I've exposed as part of our model. Easy to do through NextMove, and that way you have access to them here and you can use them for experiments. So overall, cost of the schedule is this value here. We can see all our shifts are covered, so that's great. But we're seeing the shift spread metric. It's the difference between the maximum shifts assigned and the minimum shifts assigned to a worker. We see that that's 5, and the max shifts that can be assigned per worker in this particular schedule is 5. So it's not great. It means there's quite a bit of discrepancy, but it is a feasible solution. It found the optimal solution. So, and we're looking at cost here. So let's take a look at the input. So every run you have access to the input data. You can see who is available, when they're available, and the shifts that are available. And then let's also take a look at our output. So here we can see who is assigned to what shift by the model. If there are any errors, they'd be visible here. And then because this is not the easiest format to digest, I also added a couple custom visualizations. So this is the one that looks at the schedule, and we can already see what Haley's bringing up here. So worker 4 and worker 1 were not assigned to any shifts, while others had 5 shifts, which was the maximum number. And so while our business requirements are satisfied, all the shifts are assigned, our costs are minimized. From a fairness point of view, it's not great for our workers. So we've got something we need to investigate here. So let's maybe before we, in the next step, I would go into the code and kind of see like how are we actually accounting for fairness in our model. But this is a good opportunity to kind of show you how the NextMove MCP server works. And so cool. So this is, I'm in Cloud Code. We have our NextMove MCP server connected. The MCP server leverages the NextMove SDK and has knowledge of the NextMove context. So it's nice for interacting with your apps and runs and things like that. So I'm just asking it to take a look at that last production one, the one that we were just examining on NextMove, and help me understand why our shifts being unfairly distributed. All right. And so what this is doing is going into Nextmove using the SDK to understand the apps that are available, looking at the instances that's being used. This one was production. So it's making sure it has the right app. So this is our shift scheduling app. Um, it's already kind of hinting at what's happening. So it's minimizing cost while covering shifts. We're not considering fairness. So a bit of a spoiler already, but you can just see how the MCP server is going in, grabbing the relevant information and providing a summary. So yeah, it's seeing that the shifts are being distributed in the way that we saw them. They're uneven. And then it's taking a look at the actual input and output for the run that was being made. And you can see these are all the SDK interactions that are happening as part of that MCP server call. Um, right. And so yeah, digging into kind of what we already know is happening here. And it's looking at because the model wasn't there because they were simply unavailable. So it's checking, were those workers just not available, which is a reasonable thing to check, something that you might go in and do as part of the input, and so forth. So I'll give it another little second to kind of show you how it's working through it. And then it comes to the conclusion. So why they're unfairly distributed, it's only minimizing costs. So fairness was never part of the goal. And so what this tells me is I need to go back in, update the objective function to also consider fairness. So let's go back over to console. Are you able to see console? Are we good?
Yep, it looks great.
All right,
Yep.
perfect. Okay, so now we know what's wrong. I would go back into the model code, add an update to the objective function so that we consider both cost and fairness. So once I've done that, I would push a new version of the model to Nextmove. You can also do that with the MCP server. It's a nice way for managing the model release as well. And so we can see this was the initial version we were working on. It had just cost as the objective function. And then if we go back to our versions, this is the new version that now has that objective mode. So I added a configuration where we can say, consider minimizing cost, minimizing that spread between shifts, fairness, and then weighted, which considers both shift spread and cost. All right, so now let's go see how this model impacts our worker shifts and impacts the overall costs of the schedule. So to do that, and actually before I do that, I'm going to go into instances. So the way we manage versions and configuration together is through instances. Instances on Nextmove are essentially API endpoints. And so right now, staging still had that old version of the model that only considered cost. So I need to go in and add that new model. So changing the version on an instance is really simple. We just update it here, and now you can see I have that objective mode. I have a fairness penalty. Um, Sorry, my screen share is in the way. And then let's bump it down. So we're going to start conservative on that penalty. That's something that you could also test. We're not going to do that here for time's sake, but there's a lot of options there. So once we save it, now that new version is available on the staging endpoint. And what that means is other folks in my org can go in and run tests and kind of have that same configuration when they do things. And you can also set up other instances for testing and development. So this is just one example. So now we have the new model on staging. Let's go create that scenario test and see how our new objective is interacting with everything. All right, so we're going to set up a new scenario, test new objective mode. And so to do this, I've got a set of inputs that represent kind of different things that we typically see on our farm share schedules. So I'm going to start with the default week. It's on staging, so we're going to point to staging. And now we see we have access to the configuration from that staging instance. And so what scenario test lets you do is quickly fan out multiple runs to test different configurations at the same time. So you can see this created 3 sets of runs. And I'm going to do this for 4 different inputs. So I'm going to fly through this relatively quickly. We're going to just change the input. Everything stays the same here. So we're going to clone another one. And again, select a different input. We're going to test those 3 options. And then finally, our last one, we have our 4th input. All right, so we have our 4 scenarios. And then we're going to check. We've got these 12 runs. We want to run all of them. And so we can go ahead and just create that scenario test. And it gives you another check here to say, do you want to create those 12 runs just in case you accidentally went wild and have hundreds of runs and didn't want to set them all running. So we want those to run. So we're going to create it. And then that is going to show up here. So we can see it's processing the runs. We've got access to our 4 scenarios above. It should run through these quickly. If not, I'll pull up the one that's already run. All right, sweet. So we're just about there. And we've got our runs here. So you get a pivot table of results, and then you can kind of move it around to whatever makes sense. So we care about that new objective mode. So we want to see what are the values for the different objectives. And then we also want to see that shift spread. So I can set up the pivot table to show these two things. Let me close this menu so we have a better view. All right, cool. So these are our four different runs, and for each run, we can see in the table here what's the cost of the schedule. We're trying to minimize that cost, and then what's the spread between shifts. So it's the difference between the max shifts assigned and the min shift assigned for that schedule. We want to minimize that number. So if we just take a look at this first one, we can see cost only gives us the lowest cost schedule, which makes sense among these three values. But what we see, it also gives us pretty high shift spread. But if we're willing to accept a bit more cost, either of the other two options gives us a shift spread of one. And so this is a pretty marginal increase in cost. Haley, I'd be curious, do you think this is something the business might be able to handle, just increasing that cost a little bit in order to have more fair schedules?
Certainly, and especially in that first scenario, if we're looking at, 40 to $50 to make sure that we have more balanced shifts, which in turn reduces the risk of employee churn. I think that's
Yep.
certainly something the business would consider. So, and it looks like that pattern continues throughout the other scenarios that you have here. So, I definitely think
Yep.
that this is worthwhile to continue pursuing. And I'm curious though, how do we do this where it's not having to run a scenario test every single time to get these kinds of results?
Yeah, definitely. No, that would be pretty intensive, and probably error prone too, because you have to be looking at every result. Well, interestingly, in this case, if we look at some of these other scenarios, what we'll see is that the objective mode that results in the kind of best shift spread within an acceptable cost range changes. And so what that tells me is that we actually want to use an ensemble definition to make these runs. And that's because it lets us kind of set some rules about I'm okay with increasing the cost by a certain amount. And then once you have all the runs that meet that criteria, you can then say which the one that actually gives me the best result for my workers. And the same objective mode doesn't play out the same way. So let's go set that up in practice while it's fresh. So I'm going to expand this window so you can see the full menu, and then ensemble diffs are down here. So we're going to create a new ensemble definition. Um, and I'm just going to call it ensemble uh, whatever, definition one. Okay, so ensembles, as Haley pointed out in the overview, are made up of run groups and rules. And so for our run groups, we want to look across the different objective modes. So we're going to start with, we'll just do the cost only run. And so this one, we're going to be on staging for all of these. That's where our new model is. And here we set the objective mode to cost only. So we want to test what that looks like. And then we're going to add a second run group for fair only, again on the staging instance, and this is going to be fair only. And then finally, we're going to look at the weighted objective mode on staging. Weighted is here. Okay, so we have our three run groups. Now we need to create our rules. So the first rule is to minimize cost. And Haley, we didn't talk about it earlier, but what do you think would be a reasonable place to start for where we're acceptable accepting additional cost? Is 5% sound good? 10%, 3%? Kind of where do we want to start?
I think it's worth starting at around 5.
Okay, let's start there. All right, so we want to look at, so our cost is captured in our value. We're trying to minimize it. And then for relative, we are going to start at 5%. And obviously, this is something you could test and tweak, but we're going to start there for now. And then our second rule is to minimize shift spread. And so this is that distance between max and min. So this is one of those custom metrics that we created called shift spread. Make sure I spelled that right. And we can leave it at absolute zero. We want this to essentially be our tiebreaker. So once we have all the runs that meet our cost requirements, which one is best for our workers? All right, so we have our two rules here and our definition. So let's go ahead and create that ensemble. And so now this gives us something that we can use for every run that comes in. So let's go ahead and just make an ensemble run with that previous input and see what changes. So let's go back to our runs. We've got our run that we looked at before. So we're going to open it up. And then sorry, my menus are overlapping here. We can go in and just clone it and start from there. It's a nice way to kind of quickly test something out. And so we have our default week. We want to change the instance to staging. That's where we have access to that new model. And then we want to set it up as an ensemble run. And so you can see once I change that, we now see the run groups. So we're fanning out three. Here, configuration says none because weighted is actually the default config for staging. So just in case that was surprising, that's what that means. And then we have these two rules that it's going to check by. So this is going to kick off three runs for that single input instead of just one run. So let's go ahead and start it and see how this looks. All right, so the run again looks the same as before. You have your input. We'll have a summary of metrics once it's done running, metadata about the run and logs, and you'll see this new tab pop up, which is Ensemble. So here we can see overall that the result, this is the cost. If you remember, the cost before was 1440, I believe, so it's a little bit higher, but our shift spread is much better. So instead of 5, it's now 1, which means the difference between the min and max shift is just 1. And then we can see the mode that was used to get to this is weighted. So we go into Ensemble, and this is where it tells you which run was used for the output of this run. And so it's this one, and you can go through and see which runs passed or got filtered out within the first rule of cost, and then what was selected based on minimizing shift spread. And you can see this is the best one. You could inspect each of those child runs, but ultimately what you want with an ensemble is an answer. And so that's what it gives you up front in your summary and output. And if we take a look at the schedule, we see this is starting to look more coverage equality. And then here, the balance is much better than it was before. So seems like things are trending in the right direction.
So Tiff, I'm curious now, like this is certainly desirable. What does the path kind of look like in terms of rollout to production? How would we go about doing that?
Yeah, definitely. So I, before kind of moving this into production, I would want to run additional tests. One of the ones that we leverage as part of that production rollout process is acceptance testing. It gives you kind of a red, yellow, green light. Are the metrics that the business cares about staying the same or improving? And we run that across a much bigger set of inputs that give us confidence that this new model is not going to break anything, and hopefully it's also going to improve some things that we care about, like in this case, shift spread. And so once I've done that, maybe also running it in parallel with my existing model. So you can use a shadow test for that. That will give you confidence, and then you can see the result of the ensemble alongside the result of what's currently in production. And then once we ultimately have confidence, it's as simple as what we did before with staging. So you go back to your instances, and now production, we can upgrade to that new version with the multi-objective. And then once you save it, you have access to that new model version. And then every time you run with your API, it's a simple update to the payload to use an ensemble run type versus a standard. So a pretty painless switch to get this live in production.
So, and I think that shadow testing component is really compelling as well. Just being able to kind of have that comparison on production on production traffic without making production
Yeah,
impact at the time. So very cool.
exactly.
So are we using this across other aspects of the farm share business? And what does that look
We
like?
Yeah, no, definitely. Happy to show you a couple examples. So ensembles are a really useful tool in multiple use cases. This is our routing model, and we have an ensemble setup that's a little bit different than the one we just did. So this one actually um, groups runs by a solver parameter. So this is solver duration. It's not something that has a direct business kind of interpretation, but it certainly can impact the results. So yeah, grouping by different solver parameters is a common way to do it. And then the rules in this case are kind of a rank order of what the business cares about. So first we have to minimize costs, then minimize unassigned, then make sure stops are balanced, and then optimize for clustering. So it lets you kind of rank order the different objectives that we have for routing. And then a second one that I think is interesting to show is for our pricing optimization model. So this one, what we're actually varying in our run groups are different instances and different versions of the model altogether. So you can also do different runs against different endpoints here. So we have an aggressive pricing model, a more balanced one, and a more conservative one. So we want to see how that plays out, and we let the rules decide which strategy to go with. With the first thing being we still want to maximize revenue, and then we want to make our budget most efficient as possible. So some cool different ways to use ensemble definitions. I think they're a great tool.
Very cool. Well, I'm going to wrap us up here, Tiff, with a couple of closing slides, and then we can address a couple of questions. So let me make sure I've got our slides up. All right. So what just happened? Tiff covered a lot in the last half hour here. So we started with the planner, myself, reporting some worker feedback about unbalanced shift assignments. Tiff then investigated the issue and pushed a new model version with that objective function change. She then started running, she ran a scenario test using recent inputs and determined that the existing strategy that we had for assignments just doesn't generalize across the inputs that we're seeing. So then she created and tested an ensemble definition for further use. So what do you take away from this? Where we started is that most decision problems have more than one reasonable configuration. And as you saw, NextMove really allows you to explore these different configurations without having to rewrite code using scenario tests and ensemble runs. So ultimately, this de-risks deployments by allowing you to ship several candidate configurations instead of having to pick one and really just hoping that it generalizes. So I know we've only got a couple of minutes left here, but there are a couple of questions that came in. And this first one, Tiff, and I think this is probably prompted by your comment on the scenario test front of having the ability to kind of review runs prior to committing to them. But how do you kind of think about the cost of fanning out more of these runs and that perception of like, is that excessive? Is that worthwhile? Like, how do you think about that in relation to the value that you get out of ensemble runs?
Yeah, definitely. No, I mean, I think ensembles can be hugely powerful for kind of finding value for the business. So definitely important to do them. Finding that balance in runs is really critical. So it's not meant to be an exhaustive parameter search space. You want to do those types of tests before you come to an ensemble. But using the ensemble for kind of testing those edges that you know might pop up in actual runs. So um, I think it's great to kind of create it, kind of check yourself against the SLA of when you need a result to come back and how many runs you can realistically do. And then also check it over time. So you may find that one of the run groups is never coming as the best run for an ensemble. And maybe you can pull that one and put in something that's in between two others and get kind of more granularity there for your business. So it's definitely a tool to kind of keep iterating on over time as well.
Makes sense. And I think, in relation, I think we've got some folks on the solver side here that are curious about how ensembles relate to the concept of solution pooling that folks might be familiar with.
Yeah, definitely. No, and yeah, I guess just to keep it brief, so ensembles return a single solution. Solution pooling can return many and different strategies. You can return the 10 best or 10 random sample, depending on how it's set up. And certain solvers provide solution pooling as a built-in feature. So I would just say they're related but different. And within the next move context, Ensemble is a specific type of what we call a workflow, and you can set up a workflow to do solution pooling. So if you want to return more than one, then you set up a workflow that's more generic than the Ensemble definition that allows you to return multiple solutions. So related but different, I would say.
Makes sense. Makes sense. All right, I know that we're just about at time here, so I'm going to actually have us wrap with a final question that I am curious personally about what has been your interaction with customers when they've started to use this feature. Like, how do they typically react when they start leveraging this within their operations? What changes have you seen?
I would say happiness goes up. We hear from them that they get a lot fewer questions from operators about why does this run look this way or why didn't it do this or schedule this person here. And that's because it's kind of codifying the rules that they have in their head about what should win out when. And so it definitely reduces that kind of back and forth, the need for the back and forth. And when you do get a back and forth, it usually signals that maybe you need to go in and update your ensemble definition or try different run groups or rules. So I think it's a really useful tool for that conversation between the folks working on the models and the operators and the end users of it.
Awesome. All right. Well, we are going to close out for today. Tiff, thank you for the in-depth demo of ensemble runs. If we didn't get to any questions that folks had today, we'll make sure to follow up by email. So, Tiff, again, thank you very much. And until next time.
Awesome. Thanks.